Hello there, I'm Thomas Hatsios. I'm an American pilot flying the Boeing 787-900 United flight from Zurich International Airport. Then we'll fly Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport. Runway 1449 is localized and landing. So now I'm in the cockpit for the pre-takeoff preparation with the quality wings, Boeing 787-900 and Microsoft flights and later X. I'm going to start sending you the cockpit instruments that displays and the functions of the Boeing 787-900 aircraft. I'm going to start with the primary flight display. That displays the airspeed indicator, the airspeed selected from the autopilot director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the barometric pressure of the outside atmosphere, and the target altitude selected from the autopilot and flight director system panel. We have also the vertical rate of climb of the aircraft in tens, hundreds, and thousands feet per minute, or the stiffness of the trigonometric angles in can climb and descend. Also we have the altitude indicator with the pitch ladder degrees and the bank angle in degrees, the artificial horizon with the altitude indicator, also the Lszh localizer. We have the Lszh localizer, the radio frequency transmitter from the runway threshold antennas that transmits radio frequency and are received from the onboard antennas of the aircraft can be generate the Lszh localizer, the horizontal localizer and the vertical glide slope angle for approach and landing. So we use the Lszh localizer. It has a unique radio frequency for each runway and airport we use, and also we have to use the magnetic north pole heading of the runway. So we have the runway 14 in Lszh airport, Zurich International Airport in Switzerland. You're gonna see we're gonna tune the Lszh localizer frequency for that, and we're gonna use it for takeoff and for landing for alignment with the runway. So we have also the Lszh localizer crossbus. We have the flight director crossbus for manual guidance of the aircraft, and the autopilot crossbus for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode down and zero with the autopilot and the autothrottle later on vertical navigation mode. We have also the HSI, the horizontal situation indicator, that displays the magnetic heading and track, and also the graded display of the airports. The runways we're gonna use for takeoff and for landing, the flight plan we're gonna use. So you're gonna see also the navigation display. We have the navigation display. You can see the navigation display. We have the horizontal and vertical profile of the aircraft as it flies, the GPS position, the magnetic north pole heading, and the geographic north pole and magnetic variation depending on where we are in the world. You can see the terrain map from the weather radar. You can see the terrain around you displayed with a red, yellow, amber, and green indication depending on the elevation and the distance. You can see the navigation display. So we have also the vertical display of the terrain around you. You can see the mountains in front of you and below you when you fly in the terrain levels. You have also in the terrain map, you have the airports where they are located. So we have our own airport display with a 4-letter ICAO name, the Lszh, the Zurich International Airport in Switzerland, with the taxiways we're gonna use to taxi to the runways. Also the runways, the runway we're gonna use for takeoff and for landing. You can see the runway length, the heading of the runway, and also you can use other information. You can have the board stations, the ADFs, the Lszh localizer display. So we have the navigation aids, the board station, the ADFs, the NDBs. We have also the waypoints which are horizontal and vertical navigation fixes, and altitude and airspeed constraints. The aircraft we're gonna have to fly through some waypoints. During this flight we're gonna connect all the waypoints one by one using a magenta purple line. It's gonna be connected automatically from the flight management computer when we create the flight plan over here. So you will see the flight plan we're gonna create, and you will see it's gonna be connected with a line, magenta purple line over here in the navigation display. So you can see the terrain over here around you with red, amber, yellow, green. The airports, you can see diesel, the Düsseldorf airport here, DTL, our own airport, the Zurich International. Also the magnetic heading right now, the vertical over here above the ground level. You can see the aircraft when it's flying. Also the terrain elevation 4,900, 1,600. You have also the primary flight display. I will show you now. Also in the navigation display you can see we have In the navigation display, we have the display of the aircraft that fly around our own aircraft by using the transponder, the DSP and ADC. Transmitter receiver transmits our frequency to other aircraft and the air traffic control and receives from other aircraft. You can make calculations with its computer to calculate the other aircraft distance from our aircraft, the location, bearing also, how many hundreds and thousands of feet are above or below our aircraft, also whether they climb or descend with respect to our aircraft. We can calculate also the velocity closing in between our aircraft and the other aircraft. Will give us a warning from the TICA system, the traffic collision advisory system, when we are in the air to make an avoidance maneuver. Or we can also track the aircraft in the ground, in the taxiways and the runways we use for takeoff and for landing. So you can see with a diamond save the other aircraft in the navigation display where they are located and the altitude difference also displayed numerically. So we have so you can see in the cockpit we have also other things you might want to see. So we have the navigation display over here. You can see the primary flight display over here, so you can see the airspeed indicated, the airspeed selected from the autopilot flight director system panel. So we have the airspeed table will increase when we fly. The radio altitude above the ground right now, it will display up to 2,500. You can see also the radio altitude here when we fly and navigation display. So we have also the barometric altitude above the sea level, the altitude tape, and the target altitude from the autopilot flight director system panel. Also the flight director here, the altitude indicator with the terrain and the sky color. Also we have a vertical rate of climb descent of the aircraft in tens, hundreds and thousands feet per minute. You can see 500, 1000, 1500, 2000, 3000, 6000 feet. You will see this needle moving up when we climb, moving down when we descend is the vertical speed indicator. You can see also the pitch ladder in degrees. You can see 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees for pitch up and pitch down. Also the bank roll in degrees, you can bank like 5, 10, 20, 30, 45 or more degrees around from the vertical. So you have the pitch ladder degrees, the bank roll. Also you have the takeoff ground here, the flight mode annunciator, the flight director over here. Also the wings over here, level of the aircraft. You can see this symbol, black L symbol is the wings right now. The flight path also. So you have also the navigation display over here. You can see also the HSI, the horizontal situation indicator. You will see later the flight plan with the VOR ABFs right now tune magnetic heading, ABF left and right and frequency. Also the elevation above the ground level in thousands of feet. When we fly, you're gonna see the terrain in front of you, the mountains. Also we select other information. You can see the airports, waypoints, also the flight plan. We're gonna make a flight plan here using the flight management computer. It's gonna be displayed over here. So you can see also the flight management computer of the aircraft. Gonna input all the data. We have also the mouse pad. You have also the thrust for the engines, left and right engine thrust levers over here for what and off. You see how many percentage of the engine thrust available. So it will give us a warning if we have it will not configure for takeoff right now. So the warning goes off. You can see the engine indications here. So we have very important here. You can see the barometer. You can see the airspeed indicated. We have the pitot static and the pitot dynamic for the airspeed and the pitot static for the barometric altitude. The pitot tube which are controlled from the air data computer over here. We have also the flight control computers, primary flight control over here computers. So the air data computer for GPS receivers, magnetic North Pole, geographic North Pole, laser gyroscopes for alignment of the aircraft, inertial alignment with the coordinates, GPS coordinates, and the magnetic north pole. So we have also the pitot tubes, the airspeed and the altitude from the air data computer over here, the heading reference, so a lot of information. So you can see here also we have the barometric pressure here, 29.92 inches of mercury is displayed, like you can see 29.92 inches of mercury, landing altitude, radio minimums. So we set the barometric pressure over here. For the barometric altitude, we can set increase or decrease the value, turning around these switch. Inches of mercury, hectopascals, you can display either starters. So we have minimums, radio, plan, range over here. Weather radar, traffic, terrain for plan, and range is for the navigation display as well. The weather radar, the traffic, and the terrain. So inches of mercury or hectopascals, 29.92 right now. Standard inches of mercury or 1013 hectopascals, and the radio or baro minimums. We have accept, cancel, reject, the warnings over here displayed. So the barometric altitude set, and we have right now 1430 feet above the sea level, 29.92 inches. So you can see also we have some other display systems, CDU, info, checklist, communication, navigation display, ACAS. You can switch and also left and right the screens, expand the screen view, checklist, communication, and also cancel. You're gonna see later the autopilot flight director system panel over here. After a couple of minutes, we have the landing gear, extend and retract over here. You're gonna see also that the display of the engines indication. So this is most for the primary flight display, navigation display. You can see the airboards. The distance right now is 80 nautical miles. We can increase and decrease. Some other information here. So you can see the airspeed indicated, selected actually, not indicated, with the purple color is from the autopilot. Also the altitude heading, also the altitude here. Right now it's 10,000 feet. So you can see over here on the display the mountains we're gonna fly in front of you. The distance is right now 20 nautical miles. You can see from 0 to 10 to 20. We have the 5 and the 15 intermediate, so 15 nautical miles. We have a lot of terrain here increase. And now the altitude now we have selected 10,000 feet to fly with the autopilot. You can see the aircraft symbol over here. So we have 200 nautical miles per hour over here, indicated airspeed. The autopilot engages and disengages over here, switch. You can see flight director, on and off, auto throttle, left and right, engage and disengage. So we have also the airspeed. I'm gonna set the airspeed later, heading 360 degrees, altitude and vertical speed, the hold switches, VNAV and LNAV, word localizer, and approach for auto land over here. So you can see the other side also displays. So this is the autopilot panel. You see 200 nautical miles per hour. We have also Mach speed, 360 heading, 10,000 feet. Are the same values displayed here. 200 knots, nautical miles per hour, 10,000 feet, and 360 degrees heading. So I'm gonna show you all the systems before going into flight. I'm gonna show you also the flight controls, the engines, the thrust levers. You can see the thrust levers here, the flaps and the slats, the speed brakes. You can see the thrust levers movement. We have the thrust reversers here. We're deploying landing. You can see we have the auto throttle here, disconnect, disengage switch, throttle, auto throttle, disconnect. Over here, the takeoff, go around. Also the speed brakes. You can see extend and retract. the flaps position over here, extend and retract. So we set the flaps how many degrees we need. Also we have the horizontal trim stabilizer over here. You can see the engines thrust produced right now, left engine versus right engine. I will explain in a couple of minutes. So we have the flaps here, the stabilizer trim, stab trim, and the rudder trim. Also the outflow pressure from the cabin pressurization system, cabin altitude, landing gear extend and retract over here, alternate gear, auto brakes, rejected takeoff, and arm for landing. So I will explain one by one the function of its control. You see also the horizontal, we have here the horizontal trim stabilizer. This is supplied by wire aircraft. It has its flight control computers. Like in the Airbus aircraft, you can make turns with a Z limit, like 2.8 Z's in left and right turns, or 67 degrees of left and right turns with the side stick full side stick movement. So we have also you can climb in the Airbus with 1.5 G's or 30 degrees, and you can descend like minus 15 degrees or minus half G's. You can have also other protections like the alpha protection of the Airbus system, the alpha pro, the angle of attack, VLS, speed protection, maximum operating. So also we have similar things in the Boeing. We have also the auto trim, the automatic trim of the Airbus for the horizontal stabilizer. Also the Boeing has similar features. Also the Boeing 787 is more advanced. Also the Boeing 777. So when you move the yoke of the Boeing aircraft, you give a command over here to the flight control computers. You have over here in the auto position, primary flight control computers. So you give a command for movement to control the flight control computers to control to move the flight controls proportionally, or during flight to make the load maneuvers or angle limited maneuvers like in the Airbus. So we have also the auto trim system of the Boeing aircraft. You can trim the horizontal tail, the stabilizer or the elevator of the aircraft when you fly, to balance the aircraft in flight, to make more easy flying with less effort from the yoke, or the side stick. We have the Airbus with the side stick, or the Boeing with a yoke. As you can see, we have the control column here and the control wheel of the yoke system, also the rudder pedals. So I'll explain you one by one all the systems of the aircraft before we go into flight. You can see the Airbus will have the side stick priority, left and right. Also the autopilot disconnect and the push to talk button for the Airbus side stick and aircraft control. So you're gonna see also the Boeing controls are similar, no difference. If you have the yoke, just moving the same flight controls when flying. So you have the same flight control surfaces. Also we have the horizontal tail over here, the trim stabilizer. We can trim the horizontal tail of the aircraft. You can see over here, as I'm telling you. So you use this switch over here to trim the elevator up. This way you trim the elevator down this way when flying. Also you can see elevator trim, left click down, right click up over here. Left click down, right click up. So this way you trim the elevator up. This way you trim the elevator down. You pitch the nose up and you pitch the nose down as you fly. You have the elevator trim all the time available here with your hand in this switch when you're flying this control to make turns left and right, or climb, descend using the elevator. Also the rudder pedals, as you can see. So we have also here some limits, the flaps limit displayed. We have also the autopilot disengage this switch, autopilot disconnect, and the head-up display declarer. So this autopilot disconnect. So we have here also, you can see, because it's a fly-by-wire aircraft, this was the normal flight control computer channel. This is the alternate flight control computer channel. So you can use the alternate channel of the flight control computers. Nose up, nose down. Trim the elevator when you fly. Like in the Airbus, like in the Embraer aircraft, you have similar things, or the Bombardier aircraft has switches for trimming the elevator. So other aircraft have the trim wheel, like the Boeing 737 or the Airbus 320. So we see also an aircraft coming for landing right now, as you can see. It's a 737. Yes, it's Boeing 737-800. So it just landed. We have also over here, you can see the alternate pitch trim switch. You can trim the elevator up, trim the elevator down, pitch the nose up and pitch the nose down when you're flying. Parking brakes on and off like this. We have also a disconnect switch for the horizontal trim stabilizer. This red guarded switch, you see cut off switch, normal. So we have a malfunction. This is for all Boeing 737. I will show you the flight control computer. So you have the normal, the alternate, and the direct load, like in the Airbus aircraft of the flight control computer. So it degrades when you have failures from normal to alternate or direct. You have also the mechanical backup load. So you have here the hydraulics. If you lose some hydraulics that control the horizontal stabilizer or the horizontal elevator and the trim function, is gonna be degraded from the flight control computers over here. So you're gonna lose the automatic trimming. Over here you have the autopilot flight director system panel. As you can see, you're gonna lose the auto trim function. So you're gonna lose the automatic trimming from the autopilot flight director system panel, the flight management computer inputs, the flight director, and the auto throttle commands. So the automatic trimming, you're gonna lose it from the flight control computers. You have to come down here. You have this red guarded switch over here. It's like for our own Boeing 737, Boeing 747, Boeing 757, Boeing 767, and Boeing 777, and also for the Boeing 787. You open this red guard switch over here. You can see from normal to cut off, and you disconnect the automatic trim function, either the left or the right, either one or both together if you lose both. So you use only the manual trim switch over here, the alternate or the direct, the manual, the normal. So you see nose up, nose down again, elevator, trim over here, right and up, and you have the manual elevator control for the horizontal trim stabilizer all the time over here. Trim up and trim down the elevator. You can see the tag also, elevator trim, left click down, right click up, very important for the aircraft when you fly. So I'm gonna show you all the controls of the aircraft. You can see the outside view over here. We have the elevator, climb and descent, and we have also the trim of the elevator. I have this trim switch for the Boeing aircraft or the Airbus. We can use it, so we can climb and descend using the elevator like this. The rudder, make left and right turns, ailerons, spoilers, side stick, left and right. So you will see now the flight controls. of the aircraft, I will talk to you about the Newton's physics, about aeronautical and aerospace engineering, and derive some principles we need to know for flying all the aircraft and also the Boeing 787. I will show you the outside view. I will talk to you about aerodynamics of the aircraft for the air transport pilot license and the commercial pilot license, flight dynamics and aircraft theory we need to know. So I will show you the outside view. I will talk to you about Newton's physics and the theory of fluids. So we have here the outside view of the aircraft. You can see the surface area of the wings hold the weight of the aircraft when the aircraft is flying. You can see the thrust vectors from the engines propulse the aircraft forward. We have the vectors over here. We have the main aerodynamic cord over here and the center of gravity. So we have the thrust from the engines over here to propulse the aircraft forward. You can see we have the turbines of the jet engines. You can see we have the high pressure compressor and turbine and the low pressure compressor and turbine, the front section. Also the high speed starter here and the low speed starter here. So we have also the combustion chamber. You can see the exhaust gas, the cone of the exhaust of the jet blast. Also we have the bypass air from the front fan. So we have also the fuel line over here from the top, from the left and the right wing fuel tanks over here. So we have the left wing tank and the right wing tank and the center tank. So we right now have 30% and 30% left and right wing and 10% in the center. We have the main aerodynamic cord over here of the forward wings is the position where the maximum aerodynamic lift occurs in the forward wings, about 23% of the main aerodynamic cord. Also where the stall will begin. Also the center of pressure moving back and forth in the top surface of the wings. So the stall will begin in the top surface of the wings. The airflow becomes detached from the top surface as we fly, and the wings stall for a given angle of attack and an airspeed that either increase or decrease. So we need to have to apply over here the stall avoidance maneuver in the air. We need to monitor for the stall speed here all the time. When we fly, we have the primary flight display, the airspeed indicator that I show you. You're gonna see the stall speed display with a number and red indication. We need to avoid reach the speed of the stall for the angle of attack over here of the stall of the wing. So we apply thrust. We're gonna use the side stick in the Airbus side stick down, push forward, and also in the Boeing the yoke push forward to decrease the angle of attack, and advance the thrust levers to forward like takeoff setting, full thrust setting, until we increase the airspeed. So we need to balance in the air we reach the stall speed. So we have also the main aerodynamic cord here of the wings is also the left and the right wing, and the center tank is the center of gravity here, transverses over here. So the center of gravity also is what we use for the yawing axis of the aircraft. So we have the rudder to make left and right yawing turns over here. Also we have the nose wheel for the ground maneuvers for takeoff and for landing to make left and right turns alongside with the rudder depending on the airspeed of the aircraft. So we don't have an airspeed from 0 to like 45 knots, like 70 kilometers an hour. We have a deflection of about 76 degrees either left and right for the forward nose wheel of the aircraft over here. So we can deflect the forward nose wheel 76 degrees either left and right from 0 to 70 kilometers an hour. Then at 45 knots or 70 kilometers an hour, the rudder becomes aerodynamically more effective. So we can use the rudder more. It's automatically decreased from the computer from the deflection of the forward wheels is decreased from 76 to like 7.6 degrees above 45 knots or 70 kilometers an hour. So as we increase the speed for takeoff, we have more rudder, and at about 70 knots the forward nose wheel is is locked to 0 position, no deflection. So we have only the rudder aerodynamically effective at about 70 knots, airspeed or 144 kilometers an hour for takeoff. And we do the vice versa for landing. It's all automatic from the computers. You don't need to do nothing. Just use your rudder pedals to steer the aircraft for takeoff and for landing. Also in the air you have only the rudder. So after takeoff you have the rudder to make left and right turns like this, doing balance and maneuvers, the vertical stabilizer and rudder. So you use the rudder pedals like this to control the deflection of the rudder, also the forward nose wheel control. As I told you, we have also the tiller for the nose wheel. For the forward, the nose wheel is interconnected with the rudder pedals. Both rudder pedals are interconnected, both sides. In both Airbus and Boeing aircraft, you move together the rudder pedals. So we have also the other controls. I will show you now. So I have the rudder pedals in my side stick like this. So we have also the toe brakes in the top surface of the rudder pedals. You can press the brakes to slow down the aircraft in landing. So we have also this preliminary dynamic core, the center of gravity, the yaw axis. We have also the lateral axis from wingtip to wingtip over here, as you can see. So from wingtip to wingtip, we have this axis is the pitch axis of the aircraft. You can use for climb and for descent the side stick in the Airbus aircraft like this, or the control column, the yoke of the Boeing aircraft for climb and for descent like this, as you can see. So side stick, climb, descent. The elevator is the control column over here. The side stick up and down. The elevator is the pitch axis. You move the weight of the aircraft up and you move the weight of the aircraft down to descend the pitch axis of the aircraft. The side stick in the Airbus, back and forth. The yoke, whole yoke, back and forth in the Boeing. Also you can see both sides in the Boeing move together, and the control wheel. So we have also, so you use the elevator for climb and descent, rudder over here, deflection. So we have the thrust levers. So we have climb and descent using the elevator. As you can see, the side stick back and forth in the Airbus, the control column in the Boeing. So we have one more axis here from nose to tail of the aircraft. Is the longitudinal axis. So we have one aircraft coming for landing. We're gonna spot that. One more aircraft. It will take like a minute, maybe less. So we can see we have the longitudinal axis here. It's the side stick left and right in the Airbus aircraft. So we have the elevator, climb and descent, back and forth, side stick in the Airbus, left and right in the Airbus side stick. Also the Boeing, you use the control column and the control wheel. So we have the control wheel for the ailerons and the spoilers, and the flaperons of the Boeing aircraft, you can see, and the side stick left and right for the Airbus ailerons and spoilers. So there is no difference. It's basically the same flight controls configuration. You just have a side stick in the Airbus and yoke in the Boeing. Pretty easy, both of them, how to use them. Control column, I see no difference. Okay. Boeing is also very safe to use. So we have here the Boeing 787 again, 737 actually. The 800 model is coming for landing. So it's very easy actually to use either Boeing control column or the Airbus side stick, no difference at all. So we have aileron spoilers. You have full flight controls like this, as you can see. using side stick or elevator climb and descent. So I'm gonna show you one more view of the flight controls of the Boeing 787. One more view of the flight controls of the Boeing 787, and then we go for the rest of the systems of the Boeing 787 aircraft. I will show you the flight management computer, the engines, and make an engine start demonstration. Then we go for a complete flight in the end part of the video, so stay with me until the end part. You will see complete full manual flight from takeoff, climb, cruises, and approach and landing. So now you're gonna see this view of the aircraft flight controls over here. You can see also have my computer here. Hope you like it, and the whole setup from the side stick, the computer, the keyboard I have, the screen, and the mouse pad over here. So you can control everything with the computer. The side stick here I have the identical with the Airbus side stick, as you can see. All switches. So I'm gonna show you the other view of the Boeing 787 flight controls, and we proceed with the rest of the systems of the aircraft. So I hope you like it. I'm gonna show you this view. So we are here. We climb and we descend using the side stick. Also make turns left to right using the control wheel over here. So the side stick of the Airbus, climb and descend, no difference. The yoke of the Boeing flight controls are also very safe and easy to use. Climb descent, you see the side stick deflection, no difference at all. So you see my side stick from the Airbus over here. I can use it. So climb, descent. See the control column of the Boeing. Maybe a better view of the Boeing aircraft like this. Make turns to the right, make turns to the left. So you can see also we have the horizontal trim stabilizer over here. Also we have the thrust levers. We can increase and decrease the engine's thrust over here using the thrust levers. So you see the thrust increase or decrease using this thrust control over here. You see how much percent we need to set the engine's thrust over here. So we can set like 50, 60, 70, 80, 90, 100%, or idle like 20, 30, 40, 50. So we can use also, you can see the side stick again. You see the side stick deflection is proportional to the yoke deflection. Also both sides, the captain and the first officer in the Boeing, all flight controls move together. Unless you have a failure, use the override force from either side to control the Boeing flight controls. Also I'm gonna show you now the outside view. You can see here we can climb, we can descend, use the rudder, the elevator, and also the vertical stabilizer trim, horizontal elevator trim, and ailerons and spoilers. Side stick left and right in the Airbus. Also in the Boeing you have As I told you, the control wheel for left and right turns. So I stick left and right in the Airbus, and also control column up and down the Boeing and back and forth in the Airbus. So this is all flight control, so we need to know right now. As you can see, I hope you like. So I'm gonna show you now the rest of the systems of the Boeing 787. We have a few more minutes to go for the flight. So I'm gonna show you now all of the flight management computer. So I'm gonna set up the flight management computer over here. You can see I'm having the control the mouse pad over here to control the mouse pad of the aircraft. Over here we have also other controls we can use. So we have the screen over here. You can see this mouse pad you can use for the touch screen over here. The index one by one, it's performance, takeoff, approach, annunciate, landing, and other data we need to use. So we have also the fuel control for the left and right engine, you will see later. The fire extinguishers, pull out and switch, the transporter, radar trim, radio communication panel over here, satellite, high frequency, very high frequency. So a few more things, the flight management computer, so I will input all the data we need for this flight, the takeoff gross weight plus the passenger plus the cargo plus the fuel on board, what the fuel is stored in the left and the right wing. In the center tank we have 30% in the left and the right wing and 10% in the center tank of the aircraft. Right now the flight management computer is gonna calculate the center of gravity of the aircraft automatically, also the mean aerodynamic core position, the angle of stall, and the horizontal trim stabilizer for takeoff position 4.35 degrees. We're gonna use 15 degrees of flaps for takeoff for this runway. So we have the runway 14 in the Zurich International Airport. Switzerland. We're gonna use the Lszh localizer also, both for takeoff and for landing. So we're gonna select the runway slope. So we're gonna use the flight management computer is gonna calculate also the center of gravity of the aircraft automatically when we fly. As we burn fuel, the center of gravity is shifted, and also with change altitude in flight. So you're gonna see all these things. I'm gonna insert now all the data we need for the flight management computer very quickly. So I'm gonna use the mousepad here and the keyboard and the screen. So again, one more time, we need to go over here, control quadrant. So we have the navigation display over here. You can see identity position. So we have the identities Boeing 787-900 GNX engines over here, the Iraq cycle. Also the index, we have the position. We align the inertial reference, their data computer. For the coordinates, we can also make an alignment with the laser gyroscopes when we need performance here. So we use reserve fuels, zero fuel weight, fuel on board, gross weight for takeoff, cruising altitude over here. So we have a couple of things to do. Cost index, fuel freezing temperature, and cruising center of gravity. So we're gonna use first the Lszh, the departure over here, Lszh airport. Origin, destination over here, copy paste. So we use Lszh. We're gonna create a flight plan like this. runway 14, we need to use departures and arrivals now. So we use departures runway 10, 14, 16, 28. So we have 4 runways. We can select actually 2 runways with 4 direction. So we can use runway 14 over here. 1, 2, 3, 3 runways actually. So we have 0 to Alpha. This is this other instrument departure waypoints and fixes. So we use departure arrival over here. We can select either approaches runway 16, 28, 34, ILS over here, 14 ILS 16, ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. So we use ILS 14, Amiki over here, transition waypoint over here, trans this waypoint, and use the stars as other terminal arrival waypoints and fixes. We use Negria over here for approach and landing. The stars will be aligned also with the ILS localizer, the instrument landing system. So we have the route here displayed with blue, it's not yet activated. We have the first waypoint after departure, the airspeed, the distance, and the heading, and the altitude we have to set. Cancel a discontinuity here in the flight plan between the Amiki waypoints. So we have the climb to the Nigria, descent back to the Zurich 701. So we use initialize here 0 fuel weight plus fuel on board, gross weight for takeoff. We have the reserve fuel 5%, cruising center of gravity, cruising altitude over here 25,300, cost index 100%. We're gonna have the thrust limits for takeoff also. So we press execute over here, and we have the first waypoint, as I told you, second, third, fourth. We make a left turn, Zui, 6 nautical miles, 301 knots, 6000 alpha. We climb to the Nigria, make left turn 071, 26 nautical miles from Zui, flight level 22,200, 301 knots, Matif 12 nautical miles, make a right turn and start descending. Amiki 6 nautical miles, Zui 9 nautical miles, Zurich 701 6 nautical miles, 180 knots, 6000 alpha. Then we have TRA 10 nautical miles, CI 14 6 nautical miles. Also then we make left turn here to align with the runway 5 nautical miles, 170 knots, 4000, and runway 14 8 nautical miles, 140. Takeoff Goran also flaps for takeoff, and we're gonna use later flaps for landing. Center of gravity automatic 23%. And the takeoff speeds V1, V-rotate, and V2. So we can use also departure arrival, alternate VNAV, progress, FMC communications. We can hold over a waypoint, in-flight, fix, and navigation radio, tune the ILS localizer, instrument landing system, and the VOR localizer, also IDFs. So we need to start the engines right now very quickly. We'll go here in the obviously panel. I'm gonna set some lights, turn on the APU, the auxiliary power unit, in the start position, as you can see. So we're gonna use the APU to start the engines automatically using the auto start over here. So I'm gonna show you the overhead panel, what it contains. Well, we have the left and the right IDG, the great drive generator, 120 200 volts for 100 Hz frequency, 130,000 kilovolts from left and right engine, the battery, the primary flight control computers, auto, air data computer, flight control surfaces over here, battery, towing power, passenger oxygen, window heat, rammer turbine, left and right engine driven, primary and demand hydraulic pumps, left engine driving, electric. So we turn back to the on, then to the auto position. We have also the rammer turbine as a standby, hydraulic power. We have also the recorders, the cargo and APU fire over here. Also the engine, electronic control for the engines that controls the FAREX, the auto start. So we have the normal and the alternate mode of the engines. We can arm this and select the nozzles, how much fuel to remain. We can dump some fuel in flight to make an emergency landing. So we have the fuel tanks, left and right wing fuel tank, center tank. The crossfeed valve will turn it on. You can feed either engine without the primary either tank, or balance the fuel between the left and the right wing. So we use these valves to feed the engine. We have also the wing engine on the ice over here, air conditioning. Also the cabin pressurization here in the auto manual position. Also valves when we climb and we descend. Also the air conditioning, ventilation, oxygen, hydraulic fluid, also pressurization. So we have to see these systems now very quickly. All the systems in the overhead panel. We can also see and control from here. So we have hydraulic, the APU is running, oxygen and liquid cooling. So we have also the electric left and right, engine driving, IDG, 100 to 200 volts, 400 Hz frequency, the APU is running. Also the battery, main battery and APU battery voltage and the load cell. So we have the hydraulics over here. You can see where the hydraulic fluid goes, which hydraulic systems use, primarily in demand, C1, C2 electric, side of valves, also the quantity of the hydraulic fluid and the pressure, 5100 psi. So we go more quickly now. The fuel on board, you can see the left and the right wing fuel tank, the center tank. So we have 11 and 11,000 and 10,000, total 33,300 pounds. The left and the right wing fuel tanks, low pressure and high pressure, are open and feed both engines from the center of the left and the right wing. The crossfeed valve is off, but we will turn it on. You can feed either engine with other pump or either tank. Also the APU is fed from the left wing using the DC motor. You can see also we have the minimum fuel temperature down here, below which the fuel will freeze in flight. So we have to recirculate the fuel automatically. You see minimum fuel temperature minus 37 degrees and fuel temperature. So the fabrics recirculate automatically the fuel from the wings into the engines, to also the lubricant and the oil. So it will hit it. Pressurizer. Doors are closed, the cabin can be pressurized, the gear, the temperature of the brakes and the pressure of the tires, also the flight controls. We can move all flight controls here. You will see the movement, the tail, the elevator, climb, descend. Also we have, you can see here, flight controls, movement. So we have the FS display over here, maintenance over here, systems, circuit breakers, and back to the checklist, last thing to see before going to fly, before start, after start, climb, descent, approach and landing. So we go back, navigation display. We turn off both engines and restart them right now very quickly. So we turn off both engines, fuel control in the off position, and restart the engines to see how to start. So you can see fuel starvation. I will show you the messages now, also the outside view. You can see we have the engines are off right now, the hydraulics also. So we need to start the auto start system very quickly. Both auto start in the on position like this. You can see the configuration of the amber switches in the overhead panel. So now we have pressurizer from the APU above 20%. We can start the fuel flow. So you can see the N1, which is the low speed starters, have low pressure compressor and turbine of the turbofan, turbojet engine over here. So you can see we have only pressurizer. We let the fuel control now on. So you can see also we have the N2. This is the high speed starters, have high pressure compressor turbine of the turbofan, turbojet engine. The N1, which is the low speed starters, have low pressure compressor turbine of the turbofan, turbojet engine, exhaust gas temperature per engine, fuel flow per engine per 1000 kilograms, 1000 pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. So this is all the engine's indications. So you can see the engine starts starting up. We have the auto start on. The message also went off, and now we're gonna be having running engines with green indication. We can set speed brakes up, flaps for takeoff over here, and then we're gonna have to set only the autopilot here that I told you. So we have the LNAV, VNAV, auto throttle on and off. So we set the airspeed here very quickly. The heading over here. Also the vertical speed we can set over here, so we can descend like this, and we can climb. Also the altitude we can set. So now we are ready for takeoff. Parking brakes off. Once the thrust levers, we take clearance from the air traffic control. So the runway is open for us for takeoff, as you can see. So we use the tiller for alignment here and for takeoff. You can align using the tiller like this. So we advance the thrust levers to full takeoff power like this, and we go align also the rudder bellows. So we press the side stick or the yoke down until 80 knots, 80 nautical miles per hour. Also point the center line like this. So we have 115, 120, V1, V rotate 130. So we pitch up slightly, like 30 degrees for rotation, like 9 degrees actually, or less. So we have full takeoff power right now. Landing gear here is up, positive rate of climb. Keep climbing. So you can see we are just like 1,200 feet above the ground, 1,400. So you can see we are 2,100, 2,200, 300, 400 above the ground, but 4,000 above the sea. The airspeed 185 knots. The pitch altitude over here, the wind direction and speed. Also you can see we climb with 4,100 feet per minute. You can see the trend line over here as we climb. Also the terrain, red, green and yellow. You can see the flight line. Also you can see the terrain indication. We look closer, the engines also. So you see the terrain as the aircraft flies is displayed 4,400 feet above the ground over here in the vertical display. You can see the aircraft symbol here. We keep climbing and we have the terrain, this green line below us, also around us over here in the navigation display. So we need to start now turning. We look outside. You can see the departure of the runway. So we're gonna make the turn now. Make the turn. So start turning for climbing to the position, and we have 13 more minutes to end this flight as we keep climbing. So you see the indications changed over here, the air data. Also we need to make a little bit more turn over here. So we look outside, have a very beautiful view as we keep turning over here. Hope you like this view as we fly over the Switzerland, the Swiss Alps. So we make a turn here around to see what happens. You see the Switzerland, the lakes, the Germany, the France in this side. So we need to align in a couple of minutes. Keep climbing, and we have 2 more minutes to reach here. The position we have, so we have to cross through these waypoints. You can see the ground speed, the wind direction, the distance, the magnetic heading. You can see also the wind here, the distance from the waypoint. So I'm gonna cross through the waypoints here. Autopilot also setting. The engines thrust commanded right now as we're climbing. So we have the air data. You can see the stall speed here, there, and red. The airspeed 167. Keep climbing. So how do you like the view of the aircraft as we take off? Just after takeoff over here, the cockpit of the aircraft. Very cool. Boeing 787 jet aircraft. So we keep climbing. Make a little bit right turn over here. So maybe increase the airspeed a little bit. So we need to align here with the flight plan, as you can see. So we have 9 more minutes to go back to the airport for landing. As you can see, also this side, the navigation display. So we see outside what's going on. Here we have the France in this side, the Germany, my homeland. You can see in front of you, Bayern Munich, and Bavaria also, the lakes, and the Switzerland, the Swiss Alps. So we're gonna start turning right now. Overflying 30,000 feet. We need to make a sharp turn over here, as you can see. You can see we keep climbing and make the turn over here. You can see we overflying with the Boeing 787, almost 19,000 feet right now, 19,500. So we keep turning over here. We're gonna be aligned with the flight plan. In like 1 minute, we're gonna start descend back to the airport. Keep turning a bit more sharp. So we're gonna be having 32,000 feet in a couple of minutes. Gonna start the descent. Gonna have the frozen vapors here as we climb. So here they are, the frozen vapors from the exhaust of the engines of the aircraft. You can see we overflying here, beautiful view, the star sign. We have the lakes behind us, and now the Swiss Alps. So this is a beautiful view. 33,600 feet. The lakes, the France, the galaxy here. So this is how we fly Boeing 787. So we're gonna start descent now over here. So the descent, you're gonna see a bit more idle thrust, flaps retracted, and speed brakes will go up in a while. So we push the side stick down, or the yoke in the Boeing, to descend the aircraft. So we descend here, you can see. Keep descending. We need to pass through this position. Here is the airport again, as you can see. The runways, you can see them also in the display, the approach vectors that we have. So you can see the cockpit of the aircraft one more time as we keep flying on this altitude. We need to use a little bit more idle thrust now as we descend. Increase the rate of descent also. You can see the tracks in the display that we have to fly through, the runway also, the approach symbol of the runway, also the airspeed indicated right now, the Mach speed. So we need to start the turn a couple of seconds over here as we keep descending. Increase the rate of descent and also start turning now. So here we are, start the turn. Use a little bit left rudder now, making left turn, left rudder. You can see we keep descending. A bit lower. So increase the rate of turn over here as we turn. So we turn for the approach over here to align with this line with the runway. When we reach the turn position over here, we keep flying a little bit more straight now. Increase the rate of descent also, and use this approach angle here. You will see also in the navigation display the wireless localizer when we reach this point. So you can see the runway here, we are aligned almost with the runway. So landing gear now done, also flaps extended for approach. Also we're gonna have the view here for approach and landing. The outside view. So approach and landing, we need one more minute to land. So we're gonna increase the airspeed a little bit as we are approaching, because we have only 1 minute for the video to end. You see we approaching the runway. Also we have here the wireless localizer. We need to approach using the wireless localizer and the information that we have, aligned with the localizer, also with the glide slope. So we have some side wind here, some wind gusts. So we make some maneuvers with the rudder pedals and also the other flight controls to align with the runway when we have side wind. Also increase. We need to align now for the touchdown. Very close for the touchdown here. So we're gonna level off for the flare here. Leveling off the flare, idle thrust. You can see idle thrust. Touchdown, very beautiful touchdown. So parking brakes and thrust reverse, idle thrust reverser also. Full thrust reverse here to slow us down. So you can see all landing gear parts are safe. The wheels of the aircraft, as you can see,